Hey everyone, in this video we're going to take a look at the major engineering achievements of the 20th century and take a look at some of the ethical problems that come into play when we're dealing with those. The story of electricity in the 20th century is the world going from an unelectrified world and into an electrified one, and really the history of the implementation of that to the point where it's taken as a given today. Of course, aspects of studying electricity go back to certainly Benjamin Franklin, at least in this country, and also we can talk about Thomas Edison or Nikola Tesla. And what we see is that once electricity becomes available, there becomes a whole new host of things that we're capable of making and crafting if we have electricity at our fingertips, so to speak. And a lot of the aspects of electricity that end up becoming matters of ethical discourse are the way the power grid is distributed. A lot of the basis of that in this country was shaped by things that happened during the New Deal with, for example, the REA directives of FDR, which intentionally electrified rural communities, similar to the outcry we hear for high-speed internet to be available in rural areas today. In addition to the distribution notion, a lot of the problem today with the current talk of, say, the Green New Deal or various other kinds of climate problems is not just the distribution of electricity, but also its generation. And there's a lot of methods, each of which has its own benefits and risks. Coal, steam turbines, nuclear, falling water, solar power. And those generation systems are compatible with the distribution networks we have now, but it still comes up as ethical issues today in terms of how we generate that power. And sometimes not just what is the means by which we distribute it, but what is the equitable means by which it's distributed. The automobile. Even if you don't own your own car, especially in this part of the country where we live, there's not really adequate public transportation. Car is the way to get around. And what that does is it collapses distances. If we were living without cars, a trip to Augusta might take a whole afternoon, whereas for us from campus it might take a half an hour. It doesn't merely allow us to travel wherever we please, it also allows the distribution of goods and services all around the country. Think how many trucks are out on the road running on some kind of combustion engine, probably diesel. Sure, a lot of the transportation of goods is still done on planes and on ships and on trains, but the trucking system in this country are almost like the capillaries of our logistical apparatus. What it enables us to do is to travel very quickly and relatively efficiently, all things considered. To the point where this has almost become a given in the American way of life. It's expected you or someone in your household will have a vehicle, unless you live in a very condensed city like New York, where there's a robust public transportation system, but certainly not in a big city like Dallas or Houston, where sure, they have a public transportation system, but those cities are such sprawls that it's pretty ineffective to use. So in many ways, it's really necessary to own, lease, or perhaps even rent a car in this country constantly in order to get around. There are a lot of ethical issues that come up with cars. Sometimes the ethical issues are in conjunction with other things, like should someone be operating a vehicle if they've consumed X amount of alcohol. So a lot of the issues today on the engineering side of things with cars, however, come with manufacturing and pollution. So we want to reduce carbon emissions, so we'll make cars more fuel efficient. So we'll use lighter weight materials so that cars are lighter and they don't consume as much fuel on the road. But in doing so, are we reducing the structural integrity of those vehicles? Are they as safe? So then we have to create other safety measures to ensure that people are safe inside these death machines. That's why we have seatbelts and airbags and all these precautions about car seats and the way that they're to be installed for children, because a car accident, even at a fairly mundane speed, can kill you. Then, of course, there's the aspect of pollution. Should we be building cars in the first place that run on oleaginous combustion, which is a technology from the 19th century? So while you in your car, you might have the most advanced electric features. Probably most of you run on a car that you put some sort of petroleum product in it and it burns. That's an antiquated technology. We can do a lot better, but since so much of the manufacturing is already in place to build vehicles powered by fossil fuels, we haven't really changed that. It's still the norm. We might make them more fuel efficient, but the basic way they function has remained relatively unchanged. Sure, we have alternators now instead of carburetors, so it's not that nothing has changed, but the fundamental way in which they function has not really been altered in over a century. Airplanes. The issues with airplanes are analogous to the issues with automobiles. So there's some of the same kinds of manufacturing, carbon emitting problems. But what's been done with airplanes is if the car shrank the world, the plane has shrunk it even more, especially during the mid and late 20th century. Distances that would have taken months on ships centuries ago now take a couple of hours. This makes traversing the world easier in terms of time, but as we've seen over the course of the late 20th century and into the 21st century, it takes a toll on the Earth's atmosphere and climate. Whereas with automobiles, you're probably likely to own one and not own a plane. Granted, some people do. In this commuter sense, it still essentially democratizes travel across the world. You might not own your own plane, and that doesn't mean that plane tickets are completely inexpensive, but now you have the capability, at least, to travel the entire world over if you had the means to do so and you wanted to do so. Water supply and distribution. Odds are, if you're living in the United States, you have running water in your house that's tied to some sort of municipal system. Here we can talk about the supply and the distribution. In this part of the country, we have ample supply of water, but that water still goes through filtration processes that were introduced in this country in New Jersey in the first decade of the 20th century, where chlorine was added to the water supply. While other chemicals have been added to the process of water treatment, sometimes the debate is, should these chemicals be in our drinking water? That's sometimes debated. Another thing that's happened in the 20th century is not just the supply of clean water, that's remarkable unto itself, but also the distribution of water to arid areas. For example, in California, in Los Angeles particularly, there's the Los Angeles River. Originally, it was a naturally occurring river, but today it kind of functions as an aqueduct that brings water from the Santa Susana Mountains directly into Los Angeles. Electronics. Now, we've already talked about electricity, but in the 20th century, we also saw the advancement of electronics, going back to the diode, the triode, the transistor, and then we keep getting transistors that are smaller and smaller and smaller and smaller, to the point where transistors end up becoming so compact that our electronic devices are themselves more and more compact. Look at a cell phone in the 1980s versus a cell phone today. Now, as these transistors get smaller and smaller, they end up being cheaper to produce, and thus lend themselves to the consumer side of things, which is really where we see them develop. For example, 1954, you see the first transistor radio, which was made by Texas Instruments, the same company that goes on to put their little transistors in calculators, which, to my understanding, high school students still have to buy. These shrinking transistors allow for the eventual invention of microchips, which is what we see in computers and game consoles and all kinds of other devices today, because the processing that used to have to be done on giant rolls of magnetic tape can now be done in a space that's getting increasingly smaller. Think of how many electronic devices you have right now. Certainly, this media right now that you're consuming on an electronic device. I'm producing it on an electronic device. I'm editing it on an electronic device. If I look at my desk, I've got a tablet, I've got 2 monitors, I've got a cell phone, I've got my earbuds, I got another thing of headphones, speakers. I'm surrounded by a litany of electronic devices. What are the potential dangers here? Well, certainly these electronic devices consume electricity. And there are often conversations about their equity too. Should a phone cost $1,000? When at the same time, people are getting paid pennies on the dollar to actually manufacture it. Occasionally someone will say, oh, I can't believe these people are getting the newest iPhone, when in our contemporary world, even a cell phone ends up being a conduit to all kinds of necessities that we have today. It's not really some kind of luxury. Radio and television. Now, a couple of these, and some that we'll see later, you might think might be subsumed under the notion of electronics, but radios and television are a bit different because what they allow for is the rapid distribution of information, much like the printing press. We'll see this a little bit later when we get to the internet as well. What happens with radio is you're able to communicate things very quickly. And even with the advent of telegrams in the 19th century, where communication was fairly rapid, but it had to be done through specific channels. Radio, well, yes, technically radio and television have to be done through specific channels as well. Usually, those channels are distributed in such a way that they're much more easily accessible than that which is limited to a telephone wire. But another thing that's interesting with radio is it's free to use its FM and AM bands. I can go in my car right now and turn on the FM radio and listen to whatever I want without a fee, unlike, say, Sirius Radio, which charges a fee, or any other kind of subscription service. Same thing with television. There are local channels that transmit signals now that are in high definition, but those are accessible to all. If you want to sign up for other kinds of television services, whether those be cable or satellite or subscription services, you can do that if you want to, but there are local channels accessible to everyone. And so that, again, democratizes information in a new way. Here, the ethical aspect is the production of materials, certainly, but what this allows for is rapidity rapidity of communication. It's a technology that's a creation of engineers, but also it brings new aspects of notions of free speech and communication into the equation. Can people say whatever they want on the radio and television? No, we have regulators that regulate what can be transmitted. Now, that's not really something that comes into play in engineering, but on the other hand, how is this stuff produced? Can I just start transmitting my own FM signal whenever I want to? Are there health problems associated with television? But just like automobiles and airplanes have made the world smaller in terms of what we have to do when it comes to travel, radio and television have shrunk the world in terms of the way that information travels. Something can be known instantaneously. You can watch an image on television or hear something going on the radio. You'll hear updates now. That's what happens whenever there's a big event. Images can be translated to you instantly on the television or radio. Now while it's been democratized in such a way that it's accessible to anyone with a radio or television, we'll see in a lot of ways the internet kind of continues that democratization of information. Agricultural mechanization. For some reason, there's often a tendency to look down on agriculture as being diminutive in some way, or rurality as being intrinsically denigrating. However, agriculture and farming has had some of the greatest engineering achievements of the 20th century. It's one of the places where the advancement of technology is perhaps not as well known, but it's probably where it's been the most profound in many ways. For example, at the end of the 19th century, it took 35 to 40 hours of planting and harvesting labor to produce 100 bushels of corn. That's a week's worth of work for one person. 100 years later, producing the same amount of corn took only 2 hours and 45 minutes. 40 hours to 2 hours and 45 minutes. This means that we can produce much more food for the world. On the surface, that sounds great. Agricultural advancements like modern tractors and harvesting combines, things which didn't exist hundreds of years ago, have allowed agricultural production to become almost ruthlessly efficient. Now, this means certainly we produce a lot of food. One of the ethical ramifications here is that we produce so much food that we also produce preposterous amounts of food waste as well. We have enough food in the world to feed everybody. But there are problems with the equity of distribution. That's something that comes up a lot in ethics. It's not just about the what is there, but how it is used. Computers. Now, earlier I mentioned a lot of electronic devices that we have, but computers are something specific altogether. Because while consumers in the United States have had electronics for some time, computers went from being something large, bulky, and probably only in the workplace, really in the 1970s and 1980s, becoming something that was in every home. A personal computer. Computers started out as basically glorified calculators, but then companies started using computer programs for their own benefit. For example, as early as the 1950s and 60s, a computer program made by IBM was used to schedule flights in the United States. What computers allow for is also the programming of other automated systems. I think the most relevant problem here as programming advances is the notion of AI. Now, when I talk about AI here, artificial intelligence, I'm not talking about like Skynet taking over. What I am talking about is how we program machines to do very complex actions that might even have a moral element to them. For example, in a self-driving car, how do you program it to deal with unexpected anomalies? Someone's walking out in the street where they ought not be. Do you slam on the brakes if it causes the people behind you to slam into you? Or do you take a calculated risk and run over a pedestrian? How do you come to that decision? How do you program a machine to make that decision? Is the machine responsible for its actions? Is the programmer responsible for its actions? We see this come up with companies like Google and Tesla wrestling with this kind of stuff today. The telephone. Now here I don't mean the modern advancements of the cellular telephone. We covered that earlier when we were talking about electronics. I mean just the basic telephone communication, talking from one person to another. Earlier we talked about television and radio as democratized communication. Radio and television typically are one-way communication. Most consumers have television or radio receivers, but not transmitters. So you can get information coming to you that's produced by various corporations and regulated by the federal government. The telephone, on the other hand, allows private two-way conversation. I can talk to you, you can talk to me, and it's private. Or is it? So some issues that come up here are the very notion of privacy. Do we have private conversations? And it's been demonstrably shown that organizations like the NSA have spied on the conversations of private citizens. It has happened. Now that seems like it would be a violation of the Fourth Amendment, but since September 11th, 2001 and the Patriot Act, this has come up as an increasing problem regularly. Certainly, the FBI spied on private citizens in the past. This is well known. And so this has really always been an issue with telephones and them being wired. But the telephone changed the way that we communicate with each other. But the telephone changed not just the way that we receive information. Radio and television have had a huge influence there. The telephone shaped the way that we communicated to each other in the 20th century. Text messages and emails are something a little bit different. Refrigeration. And I'm including air conditioners here too, because air conditioners, whether they be in your car or in your home or in your workplace, are refrigerating units. They refrigerate the air. So this is something that we really take for granted in the 20th and 21st centuries, especially in a place like this, which is pretty hot. Just think for a moment what it would be like without refrigeration. Sure, we can be outside on a hot day. We go inside, we feel the air conditioning, it's nice, it's pleasant. That we could perhaps imagine living without. I have a hard time imagining that. But imagine what it would be like without any kind of refrigeration. Food doesn't keep. You have no food storage. You have no refrigerator in your house. What do you do with your leftovers? What do you do with the things that you buy at the store that need to be refrigerated? You don't. And so sure, people used ice blocks and salt and other kinds of preservatives to keep things going for millennia. But what the refrigerator allows one to do is to preserve what one has for much longer than would be previously thought possible. And of course, it also allows us to keep cool. Speaking of preservation, not only do we have refrigeration in our homes, but we have refrigerated transportation. We can take objects from point A to point B in a refrigerated environment. However, air conditioning and refrigeration has a huge electrical cost. I know this myself. My electric bill doubles in the summer from running the air conditioner, and I don't run it particularly low. I wish I would, but I know how much energy that consumes, and I also know how much money that's going to cost. And also, the refrigerator or freezers in your house also consume a ton of energy as well. So it uses a lot of electricity, and it's probably the greatest exacerbator of the carbon footprint in your home. I know we think about modern conveniences being things like cell phones or TVs or gaming consoles, but the refrigerator has been a staple for almost a century, and it's perhaps one of the most essential items we have in our house that maybe doesn't get as much credit as it deserves. Highways obviously are the means by which we travel on those automobiles, at least most efficiently. They have a similar function as airplanes. They allow us to travel quickly from one place to another because of the extant infrastructure. And at least in the United States, I have in mind here the Eisenhower interstate system, which began its implementation in the 1950s and is continuing to add interstate highways every so often. Consider how efficient the interstate systems are, connecting various metropolitan areas. While certainly the interstate system was developed and implemented very quickly, its maintenance has been problematic. Roads and bridges in this country are continuing to decay without the proper means to maintain them. Now, sometimes this has to do with the allocation of funds, and other times this has to do with the sheer volume of maintenance that needs to be done. And also in the construction and maintenance of highways, it's not as simple as just laying concrete or asphalt on the ground. All kinds of considerations need to be made. Sometimes with regard to civil engineering and planning, how does this fit in with other aspects of development or simply what's there? Also aspects of the effect on the environment. How are all these cars on the road going to affect local wildlife? What does it do to the nature in that area? How are animals and plants affected? Does it increase the likelihood of fires? Or consider aspects of drainage. If you have all this asphalt and concrete and it rains, water doesn't just seep into the concrete, it runs off. But if you have a lot of concrete, that water will build up and it could actually increase flooding. This is what we saw happen in Houston, Texas during Hurricane Harvey. There's just so much concrete on the ground because it's such a large sprawl of city. When there was flooding, the water went straight up because there wasn't as much ground for the water to seep into. So here, again, there are engineering concerns all around. What do we do with the water? How do we get to the materials to these particular locations? How does the construction of the highway itself and the use of the highway affect the environment? And then also the ethical problems of maintenance. Who's responsible when a bridge collapses? Often, when a bridge collapses, especially when there are people on it, the question is asked, who can be held responsible for this? Is it the fault of the engineers, the regulators, the people in charge of maintenance? Who? One of the most amazing feats of the 20th century was the advent of spacecraft, the construction of vehicles that could penetrate the very heavens, transcend the atmosphere, and even land on other objects in the solar system. Not only are the spacecraft modules themselves fascinating in terms of how they are designed and function, the sheer magnitude of engineering ingenuity it took to figure out how human beings could construct objects that could reach escape velocity and had the power to escape the hold of Earth's gravity. Of course, the space age began with the 1957 launch of the satellite Sputnik and continues to this day. And what are the ethical ramifications here? Now, obviously, one of the things we could talk about here is the accidents that have happened on, say, the Apollo missions or with the Challenger space shuttle. Those are obvious. But some of the other ramifications of the fact, since spacecraft are far more ubiquitous than they used to be, there is a bunch of trash floating above the planet Earth, satellites potentially bumping into each other. It doesn't seem like it's a problem of stuff coming down, that those things would burn up in the atmosphere anyway. But things bumping into each other and colliding with each other and making a lot of interference. And then, of course, there's also the ramifications of what some of those satellites do. Sure, they might be used for international cooperation, like in the International Space Station, but they also might be spy satellites used for espionage as well. The internet. You're either using it right now to watch this video, or you used it to download this video. And especially in the last quarter century, it's also become ubiquitous. Although it's a bit older than that. Originally, it was just a networking of computers called ARPANET that were used to link up universities and other research institutions working on projects for the United States military. Much of the broadband cables used to transmit high-speed internet today were actually laid down several decades ago by telephone companies, which is part of the reason why telephone companies have such a monopoly on the internet market. Like telephones, television, and radio, the internet is one of these democratizing features. For example, in the palm of your hand, on your phone, you pretty much have access to the entire world's database of knowledge. Do we use it? No. We have access to more information, texts, images, sounds, than any other human beings in history. Do we use it to its full capacity? Surely not. Which ends up being a question, is it good for us? I'm not answering the question one way or the other. I'm just saying this kind of stuff comes up. It's not just about violent video games. Neither am I simply talking about people being addicted on social media apps, but these health concerns are things that do come about with the access to high-speed internet. And also, what's on the internet? It used to be, for example, when it came to pornography, if you wanted to view it, you were going to have to go to a store that sold it, take your items up to the counter, and purchase them for the clerk to see. Now, you can access pornography on your phone. But not just you, so can children. And this becomes another concern. The accessibility of what's out there. Sure, there's free speech concerns, and there's children coming into contact with all kinds of things. Is this right? Should the internet be regulated in other kinds of ways? So you'll notice with a lot of these technologies, the aspect of regulation, regulatory agencies, questions of regulatory actions that we should take come up all the time. And the internet is such a recent one of these engineering achievements that really the regulatory framework of exactly what to do with it is still kind of up in the air. Where identifying, say, harassment online or inappropriate behavior becomes a little bit fuzzier to figure out. Imaging technology. Now, surely imaging technology involves, of course, photography and videography. But I don't merely mean that. Sure, one aspect that's interesting about imaging is the fact that consider we, as people in the contemporary world, consume more images, perhaps even in a day, than people might have seen in an entire lifetime centuries ago. In terms of symbols and pictures and icons and things that we recognize. Things that we see, little images. Obviously, we see the same stuff with our eyeballs as people saw in the past, trees, rocks, and so forth. But I mean particularly images, the sheer volume of different things we have seen throughout our lifetime is incomparable to other periods of time. We've consumed so much, we've seen so much. I don't just mean aspects like photography and videography. Other kinds of imaging as well. And by that I mean ways whereby we are able to image and ascertain aspects about the world in a represented fashion. Now, surely that includes things like radar, being able to transmit radio waves, have them reflect back, and then produce an image which represents what's going on in a physical 3D world. Of course, this comes in handy for combat, but that's not the only kind of imaging I have in mind. Mammograms, electron microscopes, X-rays. All these are examples of imaging technology, where we're able to see things in ways that our normal vision cannot see. One that we use often is the Doppler radar. That's imaging technology. It doesn't mean when it's red on the map, there's all of a sudden red clouds overhead or green clouds up in the air. It's representing certain kinds of data in a way that translates what's going on in the physical world, not into some new kind of vision, but into some kind of medium which we can interpret to understand what's going on around us. This also includes a lot of medical technology, MRIs, CAT scans, all different kinds of imaging technology, again, allowing us to see in ways that our eyes don't see and then represent that information in a way that's easy for us to digest in some kind of image. So the technology here is not just the technology that takes in the data, it's the ability to take that data and produce an output that allows us to visualize that information in a way that we can understand. This technology would also include the images acquired by the Hubble Space Telescope. Now, one aspect here we could talk about are the fidelity of these images. For example, Hubble Space Telescope, those rendered beautiful pictures, usually those images are actually infrared that's been converted into a visual spectrum, which means all those beautiful nebulae with all those different colors. If you were out in space, that's not what you'd see with your eyeballs. You'd see the black shadow of space. Those colors have been manipulated in the images to represent various ionized gases. But another aspect that might come up is the potential damage of these imaging technologies as well. You know, if you've ever received an X-ray at the doctor's office or at the dentist, you'll notice you might be wearing a large lead vest, or other people might be wearing lead vests as well. Usually not damaging for a couple of exposures, but consistently over time, they can cause all kinds of damage. Household appliances. These are numerous, but also considered quite standard. Irons, toasters, ovens, stoves, microwaves, washing machines, dryers, all the things that we consider contemporary convenience and you expect to be able to at least have the hookups for when you move into a new place. Again, some of these larger appliances consume lots of energy, so one of the moves in recent years has been to make a lot of these appliances as energy efficient as possible. But also with some of these appliances, there's all kinds of potential problems. How robust do you have to be in your warnings that you shouldn't be holding your hairdryer in the bathtub filled with water? Or that you shouldn't put metal in the microwave? If you don't empty your dryer lint, your dryer might catch on fire. These household appliances have made life much more convenient in the 20th and 21st centuries, but they also come with a lot of potential dangers sometimes we don't recognize. So consider the fact that small appliances, especially toasters, hair dryers, hair straighteners, curling irons, and all the warnings that come on those items because of things that have definitely happened in the past. Some of those warnings are attached right on the power cable in such a way that they can't be easily removed. And often they're there in at least 5 or 6 languages. Medical technology. I mentioned before already imaging technology, so there's a little bit of overlap here, but also think of artificial hearts, pacemakers, kidney dialysis machines, synthetic replacements of, say, hips, open heart surgery, various kinds of laser surgery, soft contact lenses, and even elements of the Human Genome Project. The various research programs of the 20th century have caused all kinds of advancements in at least medical science and capability. That doesn't mean that you can afford it, but a lot of advancements exist. There are ailments that are treatable now that were thought unimaginable to be treated years ago. Does that mean everything is cured? Surely not. But the advancements have come a long way in the last century and a half. Of course, the ethical conundrums here are life-saving elements, of course. When should these procedures be implemented? Are there any adverse effects to various kinds of transplants or synthetic components or various prostheses? And then sometimes engineering aspects hereof have to do with distribution. How, for example, does a vaccine get produced? So often we hear about medical studies. How are things studied to be effective? How are they developed? But also, we can talk about the ethical dimensions of how vaccines are distributed. Petroleum and petrochemical technologies. Earlier, we were talking about automobiles, and automobiles need not necessarily run on petroleum. But petroleum is a kind of biofuel that is essentially constructed of the leftover remnants of biological organisms that lived millions and millions of years ago. And the residue that remains of them is full of energy that can be used for consumption today. And we use it. And most of the time people think of petroleum being things like gasoline or diesel or fuels for vehicles, which it certainly is, and that ends up being a problem because of the carbon emissions that it produces. But not only that, we can talk about the problems of drilling and accidents that happen with oil spills and oil leaking out into the ocean and the damage that causes to the natural environment. The construction of pipelines crisscrossing the country and how that affects the lands of indigenous peoples, where these pipeline conduits often bisect or attempt to bisect. Keep in mind that some of the feedstocks for certain kinds of plastics are also made from petroleum as well. Petroleum is not just used for fuel, it's some of the building blocks for some of the everyday plastic items that we use. Lasers. So laser technology allows us to transmit light in a tight beam very quickly over long distances. So in other words, it can carry a lot of information very rapidly. Fiber optic technology is also an aspect of laser technology too. This is why for a lot of media where there's a lot of information, for example, console video games and Blu-ray discs use a laser to transmit the information off the disc onto the system. For example, even on the Xbox or the PS4, the way the information gets off a disc and onto the console is through the use of a laser to transmit the data that's on the disc very quickly into the console. Then, of course, the console goes through the process of rendering that information into an image that you see on your screen. But the laser technology is what gets the information off the disc. And lasers work through the transmission of light being produced through electromagnetic radiation. So benefits here, lasers are used for all kinds of things today because of the precise electromagnetic radiation. It can be used for the transmission of information. There's laser surgery in the eyes. There's laser tattoo removal and so on. So we also see its implementation in medical technology. But then we also know lasers can be damaging as well. You're not supposed to point a laser in your eye, for example. Nuclear technology, which includes, of course, both fusion and fission. Nuclear technology can be used to great avail for the production of electricity. Nuclear reactors, in fact, can work much more efficiently than other means of electrical production, but the waste produced therein is very, very, very dangerous. And there have been nuclear meltdowns in the Soviet Union, in Japan, 3 Mile Island in the United States. There's also the other aspect of nuclear technology, which is weaponry. The atom bomb, the hydrogen bomb, and the nuclear weapons of today, which fortunately have not been used, which are outrageously more destructive than the ones used in World War II, have been a looming threat over the 20th and 21st century. Of course, the ramifications of nuclear weapons are obviously their magnitude. It's not like a conventional weapon where a very small area is taken out. The enormity of their capability is entirely unprecedented by anything in history except for perhaps great diseases of the past like the bubonic plague. But even then, that doesn't match the total destruction that comes with the use of these weapons. Keep in mind, the bombs used in World War II on the Empire of Japan in Hiroshima and Nagasaki were minuscule compared to the ones today. And also keep in mind that the American bombing of the Empire of Japan was the only time in history that nuclear weapons have ever been used on people. There's the ethical ramifications of that as well. Should that have been done? Are these weapons that should be used on people indiscriminately? And that's a separate discussion for another day as to whether or not their use was warranted in World War II. And there have been entire tomes written on that very subject. But certainly that comes up as an issue with weapons of this magnitude. Should they even exist? And there are calls for all nuclear weapons all over the world to be completely excised and taken away from even being in use by anyone, while other nations strive to enrich uranium to have at least nuclear capacity for themselves, because if other nations are going to have it, they should at least have it too. Nuclear technology is one of those things where it can be talked about as a great destructive force, but also as a means by which to generate all kinds of energy on the planet without consuming fossil fuels. The advent of nuclear technology was considered so significant in the 20th century that it's dubbed the atomic or nuclear age. High-performance materials. The steel that we have today is better steel than has ever been produced on the planet Earth. We also have other metals like titanium, various kinds of synthetic polymers and ceramics which are used in all kinds of construction for today. So this allows for the construction of materials that are wholly more resolute, hugely advantageous in the construction of buildings that are prone to hurricanes or earthquakes, even though sometimes these more advanced materials can be quite costly. These high-performance materials have lent themselves to life-saving items like Kevlar or fireproof materials. But also high-performance materials have been used in warfare. They're essential to the notion of stealth technology, but also various kinds of protection from weaponry, like bulletproof glass. High-performance materials today would also include different kinds of nanotechnology. Even materials are being constructed on the molecular level to perform certain tasks. So we've seen some of the ramifications there. Some of these materials are used for life-saving measures. Some are not. And nanotechnology especially gets us into new domains of privacy that no one prior to the advent of nanotechnology could have ever even fathomed. So now that we've gotten into a little bit of some of the aspects of engineering, what we're going to do from here is we're going to go on to the notion of moral responsibility in engineering. We're going to take a look at the code of conduct for engineers. And what we're going to see is how does the modern engineering world, with these various technological developments that we've talked about here, how does this sync up with all those meta-ethical theories which I talked about previously, where we specifically say engineers have come together and said, here's a code of conduct. With these various technologies in view, and with the various meta-ethical frameworks in view, there's at least a kind of scaffolding put together that says, here's what we engineers ought to do, here's how we ought to behave, and here's what we ought to do. With all this technology we have, and with all the ethical frameworks that we have, here's what we ought to do. That's what we're going to look at next time.